Okay, in the previous video, we introduced classical probability and Venn diagrams. This one's going to break it down, and I think will make it a lot more accessible. So please pay very careful attention. I think this will be a great help to understanding. So we have off to the side a Venn diagram, and please note the 12% represents the overlap, so that's our intersection. Remember, the overlap is always the intersection. Doesn't mean it's independent, but it is our overlap. So because we have an overlap, it can't be mutually exclusive, because remember, mutually exclusive means no overlap. And in this case, you can have both a cat and dog. If we could only have a cat or a dog, there'd be no overlap, but in this case, you could have both. So the Venn diagram illustrates the probability that a family has both a cat or dog or both. What is the probability of having both a cat and dog? The word "and" usually means intersection. In this case, that's exactly what it means. So they want the probability of cat and dog, or cat dog, which is a fabulous show. Deserved a lot more awards than it ever received. So highly recommend Cat Dog to you guys. Then it says, what's the probability of having a cat? All right, so we're looking at the probability of having a cat, which is this circle right here, which is going to be the entire, not just the 18%, not just the 12%, but the 18 plus the 12. So in this case, it's going to be 0.18 plus the 0.12 equals 0.30. That's the probability of having a cat. So what's the probability of having a dog? Well, that would be this dog circle right here. So the probability of a dog equals 0.12 plus the 0.27 equals the 0.39. So there's a 39% chance that the family owns a dog. 30% chance they own a cat, 39% they own a dog, 12% chance they own both. What is the probability of not having cat? So this means they're looking for the complement. We use the little c for complement. Sometimes they'll use a -1, but probability of cat. So what that means is not cat, which is 1 minus the probability of cat, which is 1 minus 0.30 equals 0.70. So there's a 70% chance that they don't have a cat. All right. What's the probability of not having a dog? So then we're looking for the probability of dog complement, which is 1 minus the probability of a dog, which in this case is 1 minus, we said 0.39. So that means it's going to be 0.61. What is the probability of not having both? So that's 1 minus, or that's the probability of cat and dog complement. So 1 minus the probability of cat dog, which would be 1 minus 0.12. And there's an 88% chance that a randomly selected family won't have both. They may have one, they may have the other, they may have neither, but there's an 88% chance they won't have both. Oh, here's neither. Well, neither is given by this area out here. All right. So how do I go about doing that? Well, remember, this whole thing has to be a valid probability distribution, which means it has to sum up to 1. So 1 minus 0.18 plus 0.12 plus 0.27. So that's going to be 1 minus 0.57, because this part ends up being 0.57 in here, which equals 0.43. So there's a 43% chance that they own neither. I'll just put a 0.43 out there. All right. So there's my 43% chance of owning neither. And that should add up to one whole. Let's make sure we didn't make a math error. 0.18 plus 0.12 plus 0.27 plus 0.43. One whole looks pretty good. All right. So it's a valid probability distribution. Are having a cat or dog independent events? Independent. If they're independent, means we can multiply and get the intersection. So the probability of cat times the probability of dog should equal the probability of cat dog if they're independent. Well, the probability of cat is 0.30. Probability of dog is 0.39, and this is 0.12 is the probability of cat dog. Well, when I take 0.3 times 0.39, I end up getting 0.117. So 0.117 does not equal 0.12. Because they are not equal, they are not independent. All right, they're not independent because they are not equal. Now that's close, so maybe we should do some further exploration, but it appears that it's not independent, and they're not equal, so we're going to say they're not independent. What's the probability of having a cat or a dog use the formula? Or means add. As I mentioned in previous video, in the past, we've just added probabilities and didn't worry about them because we didn't have an overlap. They were mutually exclusive. But here, we have an overlap. So we're going to have to use the general addition formula, which says the probability of cat or dog, cat union dog, equals the probability of cat plus the probability of dog minus the probability of cat dog, cat and dog. So probability of cat, 0.30, probability of dog, 0.39, minus the 12% intersection equals 0.57. All right, so there's a 50% chance, 7% chance that a randomly selected family will own a cat, or that they'll own a dog, or that they'll own both. All right. So sometimes it will, and by the way, sometimes it'll say union, sometimes it'll say or. They say or, that doesn't mean they own a cat specifically or a dog, unless it says cat or dog, but not both. So cat or dog means cat, dog, or both together. All right, what's the probability of having only a dog? That's 27%. All right, because you're like, how did you do that? Well, I ignored the overlap because that's owning both. So the probability of having only a dog is 0.27. All right, what does the probability of only a dog need to be for cat and dog to be independent? Only a dog. Well, remember, to be independent, the probability of cat and dog needs to equal the probability of cat times the probability of dog. But we know cat and dog is 0.12. Probability of cat is 0.3. So we can solve for dog. When we do that, we find that the probability of dog needs to equal 0.40. So I had dog equal 40% instead of 39%, they would have been independent. All right, they would have been independent. And I should write the probability of only dog equals 0.27. All right, so probability of cat and dog, if they're independent, equals cat times dog. Well, they told us the intersection is 0.12. They said cat's 0.3, and they wanted us to figure the probability of dog if they were independent. Okay, so we're going to use what we know about this particular Venn diagram. Well, this is 0.43, and we're going to complete a table. Well, this right here is the intersection of cat and dog. Well, what's the probability of cat and dog? 0.12. All right. Probability of a dog. Well, we said the probability of a dog earlier was 0.39. The probability of dog only, 0.27, because they have to sum up. The probability of a cat was 0.30. Probability of cat only is just this part right here, 18%. All right. Probability of having neither is 0.43. That's no cat, no dog. All right. And the probability of not having a dog, well, let's add these up here, 0.27. This is going to be 1.0. This is 0.7. This is 0.61. Because remember, rows, columns all have to total up. So given someone has a cat, all right, given is always in the denominator. So we're given that they have a cat. Okay, that's 30%. What's the probability they have a dog? 0.12. Okay. Given that a person has a dog, what's the probability they have a cat? Again, intersection over given. So in this case, we're dealing with a dog, which is 0.39. And we want the probability of a cat, which is 0.12. All right. And all I did was say for this one, it's like, oh, this is my given. That's my intersection. Then I came back and did the same thing, did my intersection for dog. Okay. Please remember, intersection, that's where it crosses. This is where it crossed. Notice the crossing, because we were dealing with cat and dog, was the same. But this was given that it was a cat, so it was out of the cats. This was out of the dog. So you're not going to get exactly the same number. All right. The denominators are different because they're taken from different groups. This was taken from the cat group, and this was taken from the dog group. This was given that they were a cat. This was given that it was a dog. All right. Thank you.